All right, so Lara, welcome here. We've got you coming from Prairie Architects and an SBM board member. So we're so happy to have you here and hearing from you for what you have to say. So take it away.
All right, thanks, Laura. Let me just get my screen shared. And all right, so I think you can see everything okay?
Yep.
Okay, perfect, thanks. Okay, so my name is Lara Matzik. I'm the Sustainable Buildings Coordinator at Prairie Architects. So we are, if you're not familiar, we're an architecture prime consulting firm with sustainable project management, interior design, and located here in the Winnipeg Exchange District. So this is a common quote that we usually like to highlight. Buildings having a substantial impact on the health and well-being of people and the planet. They use resources, generate waste, and are costly to maintain and operate. A green building is the practice of designing, constructing, and operating buildings to maximize occupant health and productivity, use fewer resources, reduce waste and negative environmental impacts, and decrease life cycle costs. So this presentation will just be an overview of what makes a building or space healthier, how it can impact our health and daily lives with some design construction strategies, and some discussion regarding occupant control and health. So the Center for Disease Control and Prevention has determined that our physical and social environment are the mega factors that influence our health. And I'm not going to dive too deep into any health statistics or, burdens or relief on healthcare system, mostly just kind of high level, highlighting what makes a healthy building. So indoor air quality and ventilation, thermal comfort and controls, mental and physical health is important. And in doing so, creating access to natural daylight, views to outdoor spaces, having adequate lighting, quality and control. Our materials are extremely important, and that includes building structure, our interiors and furniture, adaptability of spaces, design and construction practices, operation and maintenance of the building by owner and users, and the tools that we use. So why it matters, I probably don't need to drill this too hard into everyone. We know that the state of our health and well-being is more important now than more than ever. Canadians spend 90% of their time indoors, and the level of pollutants inside a building may be 2 to 5 and up to 100 times higher than any outdoor air pollutants. With 3.8 million people over the age of 1 living with asthma, 2 million with obstructive pulmonary disease, and the amount of substances including gases, dust particles, chemicals, and vapors that can cause asthma in the workplace, which be occupational caused or adult onset asthma. So now more than ever, we do need to focus on protecting our vulnerable, the children, pregnant women, those with heart and lung conditions, existing or new. Healthy buildings improve cognitive performance in schools and the workplace, and things like visual, eye comfort, and health. So on the left, there was a study, it's a combined study with Harvard and Syracuse University regarding, they took participants involved in, and they put them in a non-green building setting, a green building setting, and enhanced green building setting. So no surprise that cognitive performance increased by 101% in the enhanced green building condition. It was fairly high in a green building condition as well, but sometimes our basic green buildings aren't enough. So a common term when we talk about healthy buildings is sick building syndrome. So it's a situation in which occupants of a building experience acute health or comfort related effects that seem to be linked directly to time spent in a building. So sometimes symptoms would be headache, dizziness, your hoarse voice, cold or flu-like syndrome, allergies, skin irritation, things like that. And from the diagram, you can see the different areas in a home or building that can participate in those ailments. So formaldehyde in flooring, allergens through dust or pet, mold, lead, and VOCs in your furniture and materials. So we do spend a lot of time in the winter months. We have a lot of cold winters. So, if we have poor ventilation, poor air exchanges, They've seen an increase in synthetic building materials, furnishings, personal care products, pesticides, and household cleaners. The off-gassing of, that new car smell or the new home smell is actually chemicals off-gassing into the air. Highly absorbent materials that make up a building, like drywall or ceiling tile. They absorb toxins such as cigarette smoke or high VOC products like glues and adhesives and paints and other odors that slowly release over time. So it's important for low VOC or volatile organic compound use. Humidity levels have an impact, so too high can be a breeding ground for dust mites, bacteria, mold, trigger allergy or asthma sufferers. Too low can cause dry skin or itchy eyes, disruption of the mucous membranes, or sore, scratchy throats, etc. So homes that maybe been built better with better envelopes since the 1970s maybe have paid less attention to ventilation, etc. Some of the pollutants, combustion byproducts, radon, pet dander, mold, ozone, VOCs, as I'll bring up a lot. People entering buildings can track in dirt and dust. So we have mats and grates that will try to control that when people are entering. Even outdoor pollutant sources such as chimney smoke or contaminated groundwater, or even VOCs in certain water supplies. Especially now today with the current status of the world, proper ventilation and proper humidity levels and comfort are very important. As I had mentioned already, too dry or too damp air can affect your health of your environment. So too dry, in terms of, if we're talking a virus, airborne droplets can shrink and they're lighter and they can float longer, whereas the ideal indoor air humidity the airborne droplets would contain viruses, retain moisture, heavier, fall out of the air, less likely to be inhaled. So that's sort of a side effect of the importance of proper humidity, but something now that's very important to discuss. So in designing a healthy building, one of the main components that we consider early in design are adequate daylight, natural daylight, as well as interior lighting, quality control. We consider reflectivity of surfaces to either brighten the space or maybe dim the space. We don't want too much glare, and we go through processes of daylight modeling to ensure that we don't have any high heat spaces, and we have adequate lighting within the depths of the project. And this also has an effect on efficiency as well. Maybe not needing to heat a space, utilizing sunlight and such. Tied in with daylight are views, especially having accessible views. The top left photo is of a daycare space with low windowsills, so that the young toddlers playing can have the access to the views outdoors. They see the sky, they see green, see people walking by, and really get that opportunity to connect with the outdoors. And then the bottom right are a lot of the schools that we are building in the province do have a lot more windows and connectivity through the classroom into the corridors and spaces as well. So it brings daylight from the outside all the way through the middle of the building, and just gives kids that open outdoor feel. Ventilation too is exceedingly important. In this particular image, this is a daycare where we installed displacement ventilation. So it's typical in new builds to bring in 100% fresh outdoor air. So this particular choice was the displacement ventilation was selected not only because of significant energy savings it offered, but it was the healthiest and most effective way to deliver fresh air to the lower breathing zone that small children and crawling infants occupy. So if you're not familiar with displacement ventilation, it's a very slow moving indoor air process. So it moves slowly along the floor, brings the fresh air to the first person or occupant it sees, and sort of creates a bit of a vortex of fresh air, and then it comes up and rises through to the return air ducts. Thermal comfort and control, especially individual thermal comfort and control, is very important. The basics are generally temperature, humidity, and airspeed, but you can get really fancy with smart thermostats that also include air quality, and this also aids in your energy efficiency of a home or space, and it also can monitor your occupant comfort and safety. So the humidity rule is between 40 and 60% generally. Probably most people are comfortable around the mid zone, 50%, too high or too low. You can see from the scale, too low, you start to develop dry eye, skin conditions. Too high, you sort of get to the bacteria, mold, fungus, grow, thriving. And so you just have to find the sweet spot for yourself or for the general population, as it can vary. Building location matters greatly too. The focus can be on mental and physical health, but the outdoor spaces, the connectivity to the environment, people, amenity spaces, having access to for your staff or to be able to bike safely to and from work, and a real sense of community. There are also instances where outdoor spaces can help with indoor air quality, such as, I don't know if anyone's familiar with Manitoba Hydro, the Graham Grove place where the series of hills sort of pre-treat the air coming in from the bus route on Graham to help clean the air before it gets to the indoor space. This is an example of a school, a community designed with connectivity and well-being in mind. So there's a lot of really safe walking paths that were already existing in this community. The school built after the fact, and the school adopted these walking spaces and created a walking school bus that is primarily student-led, and so it actually led to the creation of a little bit of a project or creation of a program that students could be involved in, and it benefited the community. There are social and physical aspects where parents can volunteer. It's a large immigrant community, so they could be involved in walking the kids to school. It also reduced the amount of buses, greenhouse gas emissions, less idling, so better air quality in the community, and created safer and calmer streets. So it was a great program teaching kids responsibility and community involvement. And additionally, specification of all building materials, furniture, construction practices are included in design. Active spaces, creating visibility and access to stairs, standing desks, adequate and safe storage for bikes, and accessible showers. Creation of quiet and calming rooms and spaces in schools. This is very important for children who have special needs, and special lighting levels that can be calming or cooling, as well as the importance of acoustics in private spaces. Biophilic design, connectivity to the natural environment, so incorporating the natural world, mimicking nature, green walls and spaces, certain curves to imitate nature, and mimic natural lighting. As well as source reduction, so creating spaces that can isolate chemical mixing areas, preventing cross-contamination, so mats and grates to limit tracking from outdoor air, dirt, and particulates, proper exhaust partitioning, as well as additional carbon dioxide and monoxide monitoring. So materials are definitely extremely important for new buildings. Specifically, we look at low VOC content, but now we're using low VOC emissions testing as well for basically all interior materials. So walls, floors, ceiling, furniture, your insulation, basically everything inside the envelope. So this is just a few examples of certificates of emissions testing. They did find that the low VOC content of glues and paints and adhesives wasn't quite enough. They were still emitting emissions and toxins into the air. So the requirement for emissions testing has become prevalent in the green building industry. So for flooring, they're Floor Score certified, or for carpeting, Green Label Plus. Majority of other building materials are of Green Guard Gold. There are a few other that are used. These are definitely the primary ones that we see. And products have to be retested every several years, and they have to be valid and current certificates. So there are some fancier materials that don't always, we don't necessarily incorporate these into projects, so I'm not necessarily trying to promote one or the other, but Certainteed, for example, has a drywall that does remove VOCs from the air. So all drywall will absorb toxins and VOCs. However, this one has a process where it's an inert compound that turns the VOC into an inert compound, and it remains within the gypsum board and doesn't release back into the air. So things like cigarette smoke or high toxin scents. This Buzzy is actually a lighting fixture that has anti-polluting and purifying effects. So they're a little bit fancier, and again, this is something that's not typically incorporated into a project, but it just goes to show that the industry is listening and knowing that indoor air quality is very important. And also we incorporate materials that are not susceptible to mold or growth, fungal growth, antimicrobial flooring and hard surfaces, and have easy to clean and durable spaces and surfaces. Windows are another product that, while energy efficient, also can protect us a little bit from UVA rays. Typical glass will protect you from UVB and C, but UVA can still get through. So the higher the pane, the better, especially with additional coatings. And it also can protect your furniture from sun damage, which is durability and longevity of materials. So if you do have a lot of UV light coming through, those with skin sensitivity may or may not be effective. It also affects your occupant comfort, but it also helps with heating and cooling. UV coverings or window coverings also offer UV protection as well, but they can still provide views to the outdoors, and they themselves can be antimicrobial, have low VOC emissions. It's still important, even in a winter climate, to wear your sunscreen all year round. So transparency is definitely important for a green building. So things like environmental product declarations, which include the life cycle of a product, health product declarations, safety data sheets, product stewardship, manufacturing process sustainability. So for example, certain insulation and air sealant products do have halogenated flame retardants, have formaldehyde-based binders, phthalate plasticizers, and more chemicals that could have reproductive and developmental impacts, carcinogenicity, and create challenges for those with asthma and have long-term impacts. So a health product declaration can help outline those impacts or concerns and shows what makes up the product material health-wise. A common label that will actually be seen on sometimes even environmental product declarations, but a lot of green material products is the declare label, and it works similar to a health product declaration and the EPD, and shows life cycle, ingredients, the Living Building Challenge red list, if it passes that test or not, if it's had emissions testing, as well as recycled content. The Living Building Challenge red list, or the Living Future red list, is a list that contains the worst in class materials in building history. So those that pollute the environment, create bioaccumulation, harm to construction and factory workers. And those are BPAs, antimicrobials, added formaldehyde, phthalates, VOCs, any toxic heavy metals, and more. It's a very long list. And so the Living Building Challenge really enforces the materials to be red list free. So a lot of the information on building materials can be found. The Spot UL is sort of a one-stop shop. It generally has a lot of different search materials and products. You get your Green Guard gold certificates through here generally, as well as recycled content information if you're looking at also. Many manufacturing websites have those available as well, but there's the Green Label Plus for carpets, the SDS Global for our other flooring products and furniture products, and Blue Angel is more of a European standard, but it's one of the approved, and there are some Manitoba materials. So adaptable, a product that is adaptable, such as interface, so they are able to be replaced easily. So again, it's a healthy material that you don't have to uproot all your carpeting if you did have a spill. They are also a company that are very transparent in their materials. Again, their own website is almost a one-stop shop. You can see they've got listed all their APDs, HBDs, Floor Score certified. They have low VOC adhesives and backings, recycled content, and they have a take-back program. So there's a closed loop system where they will recycle their carpeting. And they also have social enterprises with fishing line recycling through other countries. And certain products, their Intercept program has a carpet, protects carpet tile against molds, mildew, bacteria, and odor-causing microorganisms. So in general, say your carpet will last longer. And there's many products out there that are very similar, but this one's easy to access. And material reuse, reduce, reuse, recycle. Older furniture, thrifted furniture has already off-gassed. So if possible, and you're saving on renewable resources. So existing buildings as well, reusing walls and ceilings and flooring tiles is a good example of helping with some indoor environmental health control. Adaptability of spaces too is something I think now more than ever that we're looking at. You know, it used to be probably just for temporary privacy. Now we're looking at this as safety and health concerns. So adaptable spaces that have movable partitions or plug-and-play systems, putting furniture on wheels, being able to access the ceiling and the floor to move your spaces around or electrical equipment around. So it can allow for distancing as well. So it's something that's sometimes incorporated, but now we're probably going to be looking at these more than ever. Spaces that don't have access to windows. So there are lighting features out there that can mimic circadian rhythms and natural daylighting patterns. So you can control your light temperatures to suit the space for the occupant's needs. And you know, ideally we would have, everyone would have a window to access natural daylight, but there are ways around that for existing buildings and human-centric lighting. There's also occupancy patterns that can be tracked now. This one, for example, is through lighting patterns. So they analyze your data, create heat maps, look at traffic problems, bottlenecks, and pinpointing times that they occur where sanitization may need to take place, and find ways in this time in our lives to reduce employee contact, which a year ago we probably wouldn't be saying. We'd be talking about how we can bring people together, but this way we can, you know, work either way. During construction, so it's very important that we have indoor air quality plans even during construction. Not only does it protect the future occupants, but it's protecting the workers building these buildings. So practices like covering duct openings, keeping absorbent materials off the floor, keeping lids of paints and glues covered, no smoking or vaping during construction, separating activities that are going to cause dust and other debris, and just limiting your dirt that you're tracking on and off site. And this involves monthly documentation, accountability, photographing, and diligence. After construction, air quality testing or building flushes are important. Your furniture is going, like I said, going to off-gas, so you don't really want that new home smell for your building. So you can air test or flush or both as part of your indoor air quality plan. After occupancy, so these are some things that we can help facilitate for a new project, or can be facilitated through a new project, but certainly can be incorporated for an existing building. So things like scent-free policies, green cleaning or procurement policies for your day-to-day or future renovations. Training and understanding of lighting and thermal comfort controls, as well as building owner maintenance training. The importance of regular maintenance, filter cleaning. So this is where a commissioning agent is incredibly important for a new or existing building as well. Owners, standing desks, having artwork or inviting sensory simulation in dim spaces, the faux skylights, improved lighting and transparent glazing. Regular ongoing air quality testing can be still done in an occupied building and should probably be done regularly, as well as occupant surveys and reporting, as well as wellness programs. So the U.S. Green Building Council does have what they call a LEED pilot credit or innovation library. So highlights, these are just a select few that I picked, but re-entering a workspace plan, clean construction, disinfecting your space, building material hazard and exposure assessment, and more. So there are tools out there that you can use as guidance for your new or existing building. An Energy Star portfolio is a great tool for tracking your energy and water usage. There is this ARC performance database too that ties in and links with your Energy Star portfolio manager. And within ARC, you can also include the human experience through occupant surveys, air quality testing, and you can track this for your building or your portfolio and in your CO2 or VOC levels and over time, and have a score to kind of work towards. And once you have your Energy Star portfolio set up, this ties very seamlessly. So further benefits, so your improved physical and mental health, the creation of green jobs, healthy green buildings can aid in air testing jobs, sustainability coordinators, quality control for materials and manufacturers, green training, and more. We are protecting the vulnerable and preventing them from becoming vulnerable. And it's added protection against airborne and surface viruses, that peace of mind, and creation of habit-forming activities. So one of the primary tools that we do use in Manitoba or in Canada is LEED. They have 8 different categories. Each category does have tie-ins to occupant health and behaviors. The materials and the indoor environmental quality and innovation credit categories are primarily focused on materials and their health, but they tie in across the board. The WELL system is 10 different categories, and it ties with LEED quite well, but it also focuses a little bit more on the human body and the endocrine system. So within these categories is the addressing hand washing and cleaning protocols, ventilation effectiveness, emergency preparedness, microbe and mold control, mental health support, activity levels and self-monitoring, health services and benefits, nourishment, sleep support, stress support, and so on. And this is just key themes coming from WELL and how they can be tied into the world that we're living in today. The Living Building Challenges has 7 different categories, which they call petals. And again, you can see that they are focused on health, happiness, materials, beauty, biophilia, the red list materials, as well. So it is performance-based or compliance-based on actual performance, and then all projects must address must be holistic and address all aspects of the 7 petals, rather than maybe picking and choosing. So I do think that it's incredible how many schools and daycare spaces and green buildings we do have in Manitoba, and how these children are growing up knowing no other way, and the benefits of them growing up in healthy, well-lit, connected to outdoor spaces can be in the future. And I think that it's very important that we always consider the healthy occupants when we are building green buildings. As important as energy efficiency is, so are the people that live in them. And that's all for today. Thank you.
All right, so we are going to save our questions till the end, just so that we can make sure that we get our other presentation in under the time. So if you have any questions, throw them in the chat so that we can make sure that they get answered. So thank you so much, Alara. That was really informative. I did learn some things. I thought I had a pretty good handle on healthy buildings, but turns out there's lots more. That's great. All right, so next we have Amanda and Dan coming from ioAirFlow, and they are going to bring us through some of the software pieces. Are you ready to take it away?
I think so. You guys can hear me okay?
Yeah, I can hear you fine.
Seeing my presentation?
Looks great so far.
Great. Awesome. As long as the slides actually work, then we're good to go. This is my officially my first webinar that I've posted, so this is exciting. So hello everyone, my name is Amanda Sanfilippo, and I am here with my colleague Dan Lowen, and we are the COO and CTO respectively of ioAirFlow. I am just going to give a brief introduction to our company and what we're doing. And before I do that, I just want to thank Alara for that awesome presentation. That was very informative, and I think it's going to tie in pretty well to what we're going to be talking about today. Oh, yes, everything's working. So who we are and what we do. So ioAirFlow has been around. We've been incorporated since 2016, but we've been an official business since just since the beginning of this year, actually 2020. And what we're doing is we're creating the My Building Health Score. So this is a digital auditing platform that's designed for energy service companies and other organizations that offer energy audits and indoor environmental quality assessments. So engineering firms, nonprofits, even utilities. And our platform is designed to diagnose a commercial building's efficiency and IEQ problems and recommend solutions as it continues to be refined quicker, simpler, and more concisely than current manual audits. So we are a software company, and we're developing a platform specifically for these energy service companies. Our goal is to help enhance the ability of energy service companies to support their commercial building clients in optimizing their building's health and energy efficiency. So basically, we're trying to help these ESCOs alleviate some of the challenges of current energy and indoor environmental quality auditing methods because they're often very inefficient, they're very time consuming, and they can be very expensive. So just a few additional things to note about us is ioAirFlow is an environmental company at its core. So our focus is really on the reduction of greenhouse gas emissions and lowering the overall carbon footprint of buildings. We really exist to break down the barriers for Class C buildings and Class C commercial buildings, and we'll get into that, to what that means a little bit further into the presentation. So we really have a two-pronged approach to building health. Buildings should be healthy for their occupants, and they should be healthy for the environment. It's pretty self-explanatory, I think. So why are healthy buildings important? Alara discussed the health benefits of healthy buildings, so I don't want to repeat what she said too much, but just a reminder that Canadians do spend up to 90% of their time indoors. In North America, I think it's close to 80%. Guessing Americans probably in the South spend a little bit less time indoors because their weather isn't so overwhelming. But yeah, so Canadians do spend 90% of their time, and healthy buildings are important. We'll give a little some numbers just to complement what Alara's already talked about. So on the building managers and owners side, we're looking at reducing operating costs and increasing the long-term value of their buildings. So healthy buildings have, on average, a 40% decrease in energy consumption. We increase the building's operational life and a 7% increase in building asset value. So we're looking at this a little bit more on the economic side. But it's also important to note that it attracts new tenants. This is a pretty important component, and buildings are becoming more and more competitive. We'll get into what the different classes of buildings and what that means, but as an example that I like to give when it comes to buildings is actually automobiles. So automobiles have emissions, I guess, legislation. Your vehicle has to meet certain fuel emission standards in order to be able to sell it. And we saw this happen with Volkswagen a couple of years ago, where they had to settle a massive lawsuit because they forged a bunch of their fuel emission standards, and they weren't actually meeting the legislation. What we're starting to see now is the same kind of standards being put towards buildings. And so with labeling and disclosure programs and things like that starting to become more and more common, we're going to see tenants wanting to go into buildings that are publicly disclosed as being healthier and for both the environment and their occupants. So this is all really important for building managers and building owners to know. And then on the building occupant side, so again, Alara talked about the specific benefits of healthy buildings, but to give it some numbers, generally we're looking at an average of 9% decrease in operating costs, 6% increase in employee productivity, and reduced sick days and increased comfort. So this is, well, we talked about sick building syndrome, and this has been tied to billions of dollars a year in losses in North America. When we're talking about the amount of sick days and the lost productivity, there's been some studies that have been done on this. So it's just something to keep in mind. So it's important to note that building classes is more of an art than a science. If you'd like to read up on building classes, BOMA has a paper that breaks this down into more detail. But a few things to note are that the definition of these buildings can change depending on the jurisdiction. We're using this classification to explain what we do, just because it does give an idea of why we're targeting the buildings that we're targeting with our software. But when we're talking about these different classes of buildings, it's important to consider that what is considered a Class A building in Winnipeg would probably be considered in many ways a Class C building in Manhattan, as an example. So it's really dependent on what the city or the jurisdiction looks like. But just to give a general idea of what these different classes are, Class A building tends to be the most prestigious, most amenities, best locations. They tend to be managed by professional firms, which is really important because it means that a lot of the times they have engineers or energy managers on staff. They have state-of-the-art systems. So this is the way they've been designed, and the systems and the HVAC systems and the air quality and the layout and the envelope that they've been created promotes energy efficiency and promotes healthy indoor environmental quality. And a lot of them have they do have environmental certifications. So a great example of a Class A building, and Alara's already mentioned this one, in Winnipeg is 360 Portage, which is the Manitoba Hydro building. I had the opportunity to work in that building for about 2.5 years when I was working on another program, and it's a gorgeous building to work in. The air is fresh. They have water fountains in the backdrop that actually help regulate the temperature and clear the air. Even the angle that the building's been built on is to promote sunlight. So this is a really good example of a Class A building. Class B buildings, the one I have as an example in black and white here is 310 Broadway. They also tend to be run by professional firms. They're slightly older, good quality systems. Generally, they can be restored to Class A buildings. They just don't have all of the systems in place. And finally, Class C buildings. So this is really what we're focusing on. And those Class C buildings are older. So generally, we're looking at least 20 years old. They're in need of extensive renovations, less desirable location. This isn't necessarily the case in all jurisdictions. The picture I have on the bottom there of 294 Portage, it's right across from the Manitoba Eco Network, MEC, and across from the MTS Center. That's considered a Class C building. And it is in a relatively desirable area for Winnipeg, but so it's not necessarily criteria, but they have outdated curtain walls, mechanical and electrical systems. They often have obsolete they do have obsolete technology, and they have the lowest profit margins. This is really important to consider when it comes to these Class C buildings. They can be owned and operated by professional firms, but a lot of the times they're owned by smaller firms or they're owned by individuals, and their profit margins are a lot slower, which means that upgrading these buildings and promoting indoor environmental quality and energy efficiency are low priorities. Their priorities are just to make sure that they have the tenants in the buildings that they need in order to pay their bills, which means making sure that rents stay low. So why do we focus on Class C buildings? I've mentioned they tend to be the most inefficient. They have outdated systems. Even the infrastructure, the layouts don't necessarily promote healthy well-being. But it's also because they represent the majority of buildings. 70% of buildings in the world are considered Class C buildings. 50 to 80% of those buildings today will still be operational in 2050. And this is important to note because as buildings age, they become less efficient. They become less healthy. So it's important to note that even though these buildings are old, they're still going to be occupied in 50 years. And so improving them and having that ongoing, those ongoing improvements is very important to ensure that these buildings are not, they're not unhealthy, or at least less unhealthy than they should be. And as Alaire mentioned, sick building syndrome, it does cost the economy billions of dollars a year. Again, I mentioned that there's a study that was done, and this is still very, very relevant. Everything from sick days and decreased productivity and less work satisfaction there are all major factors. So we know that healthy buildings are important. We can clearly see both the economic and social implications of healthy buildings and environmental implications of healthy buildings. So why are more buildings not improving? Why are they not taking the initiative? Why are these Class C buildings not taking the initiative? Talked about it a little bit, but ultimately it breaks out or breaks into two major barriers. Now, I've been studying this phenomenon, so specifically commercial building energy efficiency and those barriers. And I've worked in this industry for about 12 years now. And I can tell you that these barriers have not really changed in the last, they haven't changed since the 90s when this phenomenon really started being studied. So I put two primary barriers here. And it's really, there are a lot of other barriers, but in one way or another, they can all fit into one of these two categories, either informational barriers. So whether it's a lack of access to information on the importance of improvements, lack of information on funding opportunities, or very importantly, understanding what the problems you're facing in your specific building is, what the costs are to have these problems continue, or what the return on investment on improving these problems are. It really does boil down to these two things. We can consider legislation as a barrier. We know that that's coming. And we can also, I suppose there's always that possibility that even if you had the money and you had the information, some people just don't care. But I would like to believe that ultimately people are good. And if they had the right information and they had access to the funds and they understood the cost implications, that they would be making those decisions. So for this reason, the most important step to increasing the uptake is helping building owners understand the benefits and issues related to upgrading your building. By understanding your building's health, you can really pinpoint the problems, you can understand the costs associated with them, and take the next step towards it. So I say that understanding your building's health is the most important step to improving it. Ironically, understanding your building's health is also the biggest obstacle. And the reason for that is because health and energy efficiency solutions are too expensive for Class C buildings. The two primary ways that we're seeing right now to understand how our buildings are functioning are, the first is the permanent installation of building automation systems. Building automation systems are great, but they are very invasive and they are expensive. And when you're a building owner and you don't necessarily have the expertise on staff to interpret the data that's coming from these building automation systems, you can't necessarily maximize their value. We're seeing some improvements. So one issue is that with the limited infrastructure from Class C buildings is wired automation systems can be much too invasive. It requires too much reconstruction, and with outdated electrical systems and things like that, it's not feasible. So we're seeing some improvements with wireless systems, which is great. And even some systems, some building automation systems that have like a third-party interpreter for these buildings. But again, these are very expensive systems, so they're not always feasible. The most common way, and the one that I've been promoting the most for the last decade, is audits. We really, really encourage energy audits and IEQ assessments, and you can hire firms to do that. But they are very, very labor intensive. It's a very manual process. The process hasn't really changed in the last couple of decades. It requires someone to walk through your building, look at loads, look at Mechanical systems look at the envelope. It's a combination of science and best guesses, and then you're writing a very detailed report at the end. And in the last 12 years that I've been working with building owners, the thing that I hear over and over again about their audits is, okay, we got this done, we got this 70-page report, I skimmed through it, it wound up on a shelf because there's just not enough time and there's not enough expertise on staff to really understand this. So that's all well and good, but we need some solutions. Again, these barriers have been very common since the 1990s. So that's where we're coming in. And we are really hoping to help make buildings healthier. And we are doing that through automation. And now I am going to pass the mic to Dan, who is going to break that down a little bit more.
Yeah, thank you very much, Amanda. So my name is Dan. I'm the CTO of ioAirFlow. I'm going to take you quickly through our technology and how we're helping to break down those barriers. So first off, a quick run through of our technology. We use what's called LPWAN. It's low power wide area network. And one of the barriers Amanda mentioned was information. And we keep information very secure by broadcasting on the ISM band. That's the industrial, scientific, and medical band. And all the data is stored locally. We don't use Wi-Fi. You may recall that back in 2013, Target was hacked through their HVAC and 40 million credit cards were stolen. That was a settlement for $18.5 million in 2017. And it was because the HVAC, their smart system, was connected to the Wi-Fi. So we don't take that approach. And as a result, we also get increased range. LPWAN has approximately 200 plus meters through a building. Line of sight is actually closer to 100 plus kilometers, but through concrete and around electronics makes it a little bit further reduced. Whereas typically with Wi-Fi or Bluetooth, you're looking at 25 to 50 meters, often line of sight. So this will allow us to test a 40 plus story building with a single base station and upwards of thousands of sensors per base station. So we get a really fine resolution of an entire building. What we're measuring right now in phase 1 is temperature, pressure, and humidity. And this helps us test building efficiency and thermal comfort. So we can often correlate outside weather conditions to identify symptoms relating to perhaps mechanical efficiencies or inefficiencies, building envelope inefficiencies as well. And we've tested many buildings already in phase 1. And our phase 2 sensors, which are going to be live as early as next week, we'll be testing for TVOCs, so total volatile organic compounds, as well as CO2. Eventually measuring formaldehyde, particulate, carbon monoxide, etc. As Alara mentioned, these are often present in typical office spaces and come from the materials in the office equipment. And all of this ties together because we're improving building health, which also includes occupant health. A quick run through of our process. So we first identify symptoms, we then translate those into problems and make recommendations. So symptoms, they're easy to identify. They could be data abnormalities. Maybe you're seeing one section of a building warmer than another one, things like that. So we track these trends, and we also quantify them by comparing them to different ASHRAE standards, such as ASHRAE 55 for thermal comfort. For problems, there are 3 main categories. There's the mechanical, so HVAC, dampers, balancing, etc. There could be the construction or the envelope. Maybe there's deteriorated insulation or lack of insulation, old windows, poor sealant, etc. Or behavioral. So that's occupants leaving lights on, electronics, office space use, etc. And then we move on to recommendations, where we automate the report process. And this both brings down the cost and improves the accuracy over time as well. And so we prioritize the top 10 problems. There could be many. Maybe we've tested the building for 100 problems and 50 were identified. Our report will prioritize the top 10, bringing this 70+ page report down to under 10 pages. And it's a much more readable, actionable report, which will also include a return on investment to help justify our recommendations. And it's also important to note that we exist to complement energy service companies, not to replace them. We're looking to help them get into that Class C market, whereas previously it was too expensive to do so. Not to say that their 70-page report isn't more comprehensive than ours. Sorry, moving along. Amanda's advancing the slides for me here. So I'm going to give you a quick example of how we've identified symptoms. Here is a floor in an office space downtown Winnipeg. It's approximately 10,000 square feet, and everything in gray are corridors. Everything not labeled in white are offices. And you can see we have some meeting rooms, boardrooms, reception, etc. So in this space, the building operator has control over each floor. So floor by floor, they can control temperature and RH set points. And this is where they place their two sensors. They take an average of it, and once it says you're at 72 Fahrenheit, that's a set point, good, all's well. Well, we came in and we placed 20 sensors in various locations around this space. Now, our sensors are wireless, they're portable, there's no damage to the space. We simply bring in and we place them often on office desks, so we're getting thermal comfort, what the occupant is experiencing day to day. So we analyzed the results, and one symptom that we found was a large pressure differential. Now, I say large, it was approximately 0.06 kilopascals, which doesn't seem like a lot, but that can equate to about 80 newtons or 20 pounds of force on an office door. If the door was closed, you'd hear a lot of whistling underneath it, and it could even just close that door on its own. Now, this is also important because in this next zone here, we found this low temperature zone where the average was quite low compared to this other area in the same office, which was this high temperature zone. And if you note that the building sensor is not included in this high temperature zone, so the building thought that it was at the correct temperature when really it was not. And what we actually found was that there was, over the course of 11 days, there was a greater than 3°C temperature differential between these two offices, between these two zones, which far exceeds ASHRAE 55. And it could be just because of that pressure differential. So from this symptom, we identify a problem. Perhaps it's imbalanced dampers, perhaps it's an HVAC system that needs servicing, which is why you're getting this large pressure differential there. So how is ioAirFlow removing the barriers to healthier buildings? It comes down to information and cost. So we have secure technology, there's no fear of hacking, and it is wireless. So we're able to test with a finer resolution than any wired system, like a BAS system or some kind. We identify symptoms, we come up with problems and recommendations with more flexibility than our wired counterparts, and the report is actionable and prioritized. And by automating it from start to finish, we bring down the cost dramatically, which allows our partners to use our services in a whole new market. And all of this comes together to promote building health and efficiency, as well as occupant health and well-being, which I think is the next click.
Yep, I just needed to unmute myself. Oh, the joys. Oh yeah, there we go.
There you go.
I missed that one. Sorry, Dan.
That's okay.
So just to wrap it up, because I know we're coming to time here. So the next steps where we are right now is we're launching in January. So we are on track to be launching in January. And right now what we're doing is our beta test. So we're partnering with ESCOs and engineering firms and any organization really that wants to provide us with feedback, test our system, because what we want to do is make sure that we're creating a software that is of value to these energy service companies. Make sure that it's complementing the work that they're doing. It's making it, well, quicker and simpler and more concise than what they're currently doing to really enable them to open up to this Class C market. So if there are any energy auditors out there that are interested in partnering with us, please don't hesitate to contact. I'll post my contact information coming up. We have partnered with 2 local firms so far, Demand Side Energy and Integrated Designs. And we are always happy to chat some more. We're also in the data collection phase. So we're looking for Class C commercial buildings to help us test our technology. I apologize if you can hear the screaming, that's my parrot. I knew that was gonna happen. If you know of anyone that owns or operates a Class C building and interested in doing a building test, right now we are offering them at really a small fraction of what we will be, because we're still in the testing phase. And we're definitely interested in partnering up with local firms. I'm sure many of you have heard it. Winnipeg isn't necessarily the best market for selling, but it is a fantastic market for testing. And we really, really want to get this up and going and make sure that more and more buildings have access to the information needed for them to really improve their IEQ and their energy efficiency. So if there are any questions, I'm not sure, I think Laura will mention that we can stick around a little bit longer if needed, if anybody else is open to that. But you can also email myself or Dan. Industry questions or business questions can come to me. If it's about the technology, I encourage you to message Dan, because he's an engineer. I am most certainly not an engineer. And you can visit our website, ioAirFlow.com. It's currently under reconstruction, so the new website should be launched in about 2 weeks. So it's pretty basic information on there for now, but it's got our contact information on there as well. And that's all for me.
All right. Wow. Thank you so much for that. That was a lot of cool and great information. I was like, when you first told me about Class C buildings, I was like, I'm not sure what a Class C building is. And now I know, which is great. I hope that I'm not the only one who learned a lot of stuff at that presentation. So thank you for that. So I do not see any questions in the chat. So if people want to turn on their cameras, they can right now, and feel free to just like jump in and ask your question. I know it's 1 o'clock, so if you have to leave, don't feel bad about that. That's fine. But if you can stay and have those questions satisfied, that's cool. And then it's also super nice to see all of your faces. So thanks for turning your cameras on, folks. But again, no pressure. Go with what feels good. Jim, did you have a question?
Yes, Dan, is the intent that the sensors be installed temporarily, or are they permanent?
Excellent question. Yeah, I didn't cover that. They are temporary. So typically we would go in for 7 to 10 days and we'd collect data over one full work week, right? So we get the occupied times, we get the unoccupied times, and we get the weekend. So within a week, we have found that statistically we're able to get really comprehensive results, although we can test for up to a month with a single battery charge on these sensors. And so we can play around with that, and we are trying to evaluate what the optimum time frame is, but it's a week. It takes about 2 hours to do a walkthrough of the space, identify prioritized areas, and it takes maybe half an hour to collect them at the end. So very low, it's not very invasive.
Okay, thank you.
Would it make sense, Dan, to do it at 2 different times of the year, during a cooling cycle and during the heating cycle? Would that make sense?
Yeah, fantastic question. And we actually are. So we've begun our data collection phase a couple months ago. So we've tested a half dozen plus buildings with many more in the queue right now. And we have intentions to go back and retest the same buildings in the same, with the sensors in the same locations to compare those. But we're working with a data analyst to try to normalize the data as well. So say you have occupied time, you're going from your setback temperature to your set point temperature, your occupied temperature, and you're going to cool the space down, right? In the summer, in the winter, you're looking to cool down your perimeter, but in the winter, you may actually be looking to warm it up, right? And if we can normalize that against the outside temperature, then it doesn't really matter if it's going up or down. If we have a negative temperature outside and a positive slope, positive temperature outside, negative slope, we can normalize that is the intent to avoid that, but we are going to test both.
Amazing. All right. Anybody else have any questions? You can just unmute your mic if you're not comfortable with the old camera coming on screen business. All right. I'm not sure how long to wait. I know that I personally need a little bit of guts. Kurt, do you have another question there?
Well, it looks like Dad had a family issue there, so I just waited until he got back. But I have another question, I guess. So, are you thinking of partnering with HVAC companies? Because looks like you're identifying issues with HVAC primarily, right? That's what you're talking about. That's the outcome of your study. Or am I wrong? Amanda's going to clarify that.
Yeah.
Anyway, are you partnering with other providers? Is what I'm saying.
So I'll answer that question. So yes, we look at mechanical, envelope, and behavioral. The idea is as our algorithm gets refined, that we're able to make more precise predictions on exactly what the problems are, and that we're also able to base it on what the buildings want. So we know that not all buildings are going to be able to afford to revamp their envelope or, change their mechanical systems. So that's why we're pinpointing these top 10 recommendations. So it's not just HVAC systems, but yes, vendors right now, we're looking at partnering. What we want eventually our platform to be is almost like an RFP format, where once the recommendations have come into play, that we'll have a large number of local vendors and suppliers that are able to provide the recommendations or implement the recommendations, and that they're able to almost bid on what that is. So right now we've partnered with right now our vendor supplier partners really just has more to do with making sure that our recommendations are in line with what they would be doing. So just reviewing that type of information. So we've partnered with a window and door company so far, and an HVAC supplier and parts supplier in the United States. And that's really just to get feedback. But as we grow and as we refine the platform, yes, definitely it's going to be a huge component of this.
I'll just add one more note. I'm going to talk a little quieter. My daughter was a little upset that I was talking so loudly. So we're looking to partner with different suppliers for more than one reason, because we've identified symptoms. And as I've mentioned, we're pretty good at that. We have an award-winning data analyst, and we can track these trends. We can say that they're statistically valid, all of this. But we have the symptoms, we need the problems as well. So experienced individuals who have been able to say, hey, I've seen that before, and this is how we fixed it. This was the problem. And so we're looking to partner not just in terms of after our analysis is complete and trying to retrofit the building, but also upfront now as we're trying to grow our database and identify problems from these symptoms as well.
I just think it's also fascinating, and I can't wait until we get a follow-up presentation with some case studies in the next year or two.
Yeah.
Awesome.
All right. Anybody else have anything else that they want to share or ask questions?
Sure, and I'll just share that, I mean, I love talking about this stuff. So if you do want to message me, it's just dan@ioAirFlow.com, and I'd be happy to follow up more if you have specific questions via email or a video chat. Just let me know.
Great. Kurt, do you have something else?
Yeah, I got another one. So okay, you've got your sensors in there for a 7-day or limited period of time. So you do your assessment and everything. But have you also thought of offering to your customer like a permanent monitoring set? And the reason I'm talking about that is if I've got an ecobee in my home here, and I've got sensors throughout the house, and I'm looking at them all the time to see what the difference is between different parts of my house. And I find it like really informative and fascinating. And when I'm thinking that somebody, the building manager, would like to have that kind of information themselves continuously, and to just keep a better record of, better understanding of how their building is operating as they go along day by day.
Yeah, great question. So our sensors are wireless and they're battery powered. And so the partner that we're working with right now, BearTech, we're using their sensors. We're not a sensor manufacturer, but what we can do, and actually are doing for an upcoming job, is we're going to evaluate the space, kind of like what I showed you in that floor plan. And we can tell you where you should place your wired sensors, because you can see from that example that placing them in the corridors probably isn't the best, right? I mean, even if you're taking an average, and there's more than one, which is great, but maybe not the best. So if we can identify the different zones and suggest where you could place multiple sensors and how many you would require, that's part of our analysis that we can do. But right now we're not a sensor manufacturer or supplier, although we could make recommendations if that was requested.
What about for like a project and design and in kind of assessing where those sensors might be more effective when we're designing a building, rather than having to worry about it after the fact per se necessarily?
Yeah, exactly. And so one job that we have, well, it's supposed to be this week, but then Monday COVID restrictions made things such that we could not go and test the space, but they're looking to install a relatively expensive building automation system, and they want to know if where they want to place the sensors makes the most sense. So we're going to go in there, we're going to eventually collect the data and then be able to say, yeah, this is where it makes the most sense to place those sensors, whether it's on new construction or something being retrofitted, as long as they have the control to actually, you know, change those different zones as well.
And probably important to note, like right now where we are with the software, like we're a very small company and we don't have the capacity to, like we really want to open the door for as many organizations as possible, or as many building owners as possible, to start retrofitting their buildings and start understanding how their buildings are functioning. And that's why we're looking at selling the software or licensing the software directly to ESCOs, because they are well-established companies that have access and have the capacity to be reaching all of these buildings. Whereas if we're going in and testing directly ourselves, we would have to grow exponentially in a very, very quick period of time, which isn't necessarily feasible on a business scale. So that's why we're kind of focused on the Class C building and collecting the data for the development of this specific software. And then once that's done, there's really a lot of possibilities for this type of sensor technology. There really are, and Beartech is working with other well-known companies using their sensor technology to branch out into other areas.